Hi, welcome to the video tutorial for a lesson called Pencils and Rulers. It's the fourth lesson in what we call the algebra strand. And this one, I think you have to be careful where you use this one because you're actually giving children a way of solving simultaneous equations that's logic and they can see where it comes from. So it'll be interesting to see how you use this, where you go with it. I mean, at the end of this activity, I always will give the pupils a year 10 type simultaneous equation. In the resources you get, there's a cartoon of someone reading a paper, and the puzzle that moves it to simultaneous equations is in the paper. So you give them that puzzle, but there are some questions you could use at the end that are like your Key Stage 4 simultaneous equation questions, slightly easier ones, but it'll be interesting to see how this enriches the understanding of your pupils. So it's called Pencils and Rulers, and it's about a shop that some pupils run in a school. So I know my daughter in her school, the year sixes used to run a stationery shop for the rest of the school, one lunchtime, one break time instead of the tuck shop. And so I was telling the class this, and they'd sell pencils, rulers. Sometimes teachers would come and buy resources because the money went for a day out for the children in the summer. And so I would say the head teacher loved this, and there is an image to go with this of someone adding up, but the only proviso the head teacher gave was that they couldn't use calculators. So I'd say to the children, why didn't they want to use calculators? Oh, because it means they're good at adding up, it's good for mental arithmetic, and children like doing it. I say, okay, that's fine. But what some pupils did, and they pinned on the wall, they came up with a ready reckoner as a quick way of working out the price of pencils and rulers because they were popular. And what you give the pupils is a sheet. Is that sheet? There are some questions on them, but I actually never do those questions I never give the children those questions because it emerges in the discussion. And I think sometimes giving children questions on sheets limits the discussion and doesn't facilitate good group work because you really want the children to collaborate, to work together, to talk, to value the process of articulating their ideas. And so you show the pupils this, and you show them that pencils cost 10 pence, rulers cost 15 pence. So if we buy no pencils and no rulers, it costs nothing. If we buy one pencil, it costs 10. If we buy two pencils, it costs 20. If we buy one ruler, it costs 15. If we buy one ruler and one pencil, it costs 25 because we're adding up the 15 and the 10. And it's important to stress the fixed nature of these values in this shop. And so what the pupils do is they fill the table in, and actually on the sheet that they get, some of it isn't shaded, and there's that one. You're forcing them to predict what that value is. So what pupils will do is they'll mechanically start filling this in. But what I often say to them is, I'm interested in you spotting any patterns that make it quick. And very, very early on, they'll parrot back that, it goes up in 15s and goes along in 10s. You then start encouraging them to look for other patterns. So that this pattern here, going diagonally up, you add 25. If you go diagonally down, you add 5. That takes them a while, but it's worth getting them to focus on that. So when they fill the grid in, you can say to them, what patterns can you spot? And focus that, a bit like a chessboard. So when you move up one and along one, i.e. buy a pencil and ruler, you go up 25. If you buy 4 pencils and 4 rulers, that's 100. That's £1. Right? Because it's 4 25s. 4 rulers, 4 pencils. And so for me, this is why we're using lessons in simultaneous equations. You're getting them to focus on moving around in the grid. So if we go up here, that's add 25. If we go down there, it's you're taking away 5. Because you've taken away one ruler, but you're still left with a pencil. So you just take away 5. And so once they've explored this and talked about this and focused on the different moves, you can talk about going up 2 and along 3 and all that kind of stuff and let the children spot their patterns. You then say, okay, we're now going to use this knowledge to to solve some problems. See if you can work out the missing value. So for this one, there's still pencils and still rulers, but what you don't tell them is the value at the start. And what you ask them to do is look for patterns and solve that one. So I would always say this is the kind of pattern the puzzle my grandmother used to do, and it really kept her mentally healthy well into a 90. So very quickly for this one, realise if you go along 5, that one's 10, you go up 8, so actually this is 8, this is 16, that's 24. And they're getting into the hang of it. You say, okay, I'm going to give you a harder one. And it's 0, 20, 24, and that one. Can you solve that one? And that will take them some time. Okay? And what you're focusing now on is the patterns that they can spot. So, I mean, I'll never tell them this. I'll let them work it down. But when you go down, you add 4. So you've gone down 28. So 1, 2, 3, 4. 4 pence is 28 pence. It's 7, 14, 21, 28. That means rulers are 3 pence. So you've got 31 and 34. And you let the children share how they've solved it. And then you say, okay, what does, and again I've mentioned this in one of the other tutorials, these numbers mean something. What does that 20 actually mean you've bought in the shop? 2 pencils. So, and you say, well, what does it mean? How would I write it down? So they say like 2 pencils plus 2 rulers equals 20 pence. Okay, what does that mean? 3 pencils and 1 rule equals 20 pence. And you say to them, is this normally how we write things out in maths? And by now, they're saying, oh, well, why don't we write that down? 2p plus 2r equals 20. And so what have we got? What's this one here? 3p plus 1r equals 24. And so what I would say is, you know how we found patterns before? Can you find any patterns in that? They've already done it here because they've used the grid, but now we're bringing an element of symbolization, i.e. in the form of simultaneous equations. You say, can you see any patterns in that? You say, oh look, that one's going up by 1, so 4p. That one's going down, no r, equals 28. You say, oh, what do you think? Have we solved it? 4p is 28, rp is 7. What do you think about that way of solving it? What do you think about that? Do you think we could do other ones? I think this often takes a while. It's a moment of realisation where the pupils, they've realised they've moved away. So again, we've got the shop, the context, the spotting patterns. We're now mathematising the patterns, and now we're formalising it using algebraic understanding. And at that point, I will usually, after the discussion, have something like that on the board. There are questions in the PowerPoint that you can use, but you've got this and say, could we solve this in the same way? Let's have a try. 5x plus 4y equals 34. 6x plus 3y equals 30. 7x plus 2y equals, and so on. And now they get the hang of what we're asking them to do. And I now prefer this way of solving simultaneous equations. And what's interesting is you're showing them the logic that these values aren't important. What they often do is they look at this, or they look at the labels on a graph and think, I can't do that because I don't know the labels. Look at this, actually all we want them to do is look at the pattern. And then if you work through the pattern, the answer becomes obvious. So I think it's a really interesting strategy, a way of helping children understand simultaneous equations.